Thank you very much, fellow Kenyans. Good evening. Number one, I would like to at least thank you all Kenyans during this period of the coronavirus pandemic. I know we are having a serious challenge in various families because corona is proving to be more of a personal financial challenge and a personal health issue as compared to any other thing. For those who can't afford smartphones, for those who can't afford bundles to access my tutorials, I would like to apologize on your behalf. For those who can afford them, kindly ensure, this goes to the parents directly, kindly ensure that you tell your children to tune in on my Facebook page, which is a verified account, Instagram account, which is HE Babu Owino, my YouTube account, which is Babu Owino TV. Let's enjoy today's lesson. During this period of coronavirus, I know there are a lot of challenges that we are still experiencing. And let us ensure that we follow the rules and regulations put by the government to ensure that we curb the spread of corona. Let us ensure that we keep social distancing. Let us ensure that we wear masks, we sanitize, and most importantly, we pray to the Almighty God to help us during this period. For those who've lost their loved ones to the virus, to the coronavirus, I would like to condole with you and just know that we are together as a nation. Let's get united as a country. Straight to my lesson. Today's lesson will be on mathematics. And before we start our lesson, the topic on mathematics will be binomial expansion. Before we start our lesson, I would like to take this opportunity at least to urge our parents again that entrust me with your children. And using this God-given talent, I will ensure that our children pass examination, their KCSE, and join universities, and through that, they will change your lives. I would like to take this opportunity again to read some of the feedbacks that we got from our students and our viewers. So we got certain information from email that was sent by Roy Muraya. You are talking about chemistry. That's a topic on alkenes. And you sent a question. I will deal with it. Wendy Wangari, hope you are doing well, Mwalimu. What you are doing is really changing the lives of our children. Burabu Abwetsa, thank you very much, Babu Owino, for caring. Another one from Edwin Osebe, online class lessons feedback. Thank you very much, Mweshimiwa. This is a good job. I have a son who's really interested in your lessons. Paul Jr., thank you, Mweshimiwa. There's one from Desmond Kirui. I'm a resident of Embakasi East and I'm a beneficiary. There's one Charles is saying I'm at Miango Secondary School and this is really helping me. It has changed me and my attitude towards these lessons and especially mathematics has really changed, and I promise you that I shall pass. There are so many feedbacks, around 220,000. We'll respond to your emails, and also on Facebook, those who've been DMing me on Instagram and Facebook, and also on Twitter, we will take this opportunity next week to respond to you. For now, kindly enjoy your class on binomial expansion. Today's date is 29th May 2020. Mathematics. Binomial expansion. So this is a topic that we are very much aware of because we started doing this topic in Form 2. At Form 2 level, before I go to the Form 3 work, at Form 2 level, we could expand by, number one, by means 2. So it can mean, so binomial expansion is an expansion of two unknowns or two values or two variables. So in Form 2, we were doing an expansion of, let's say, x plus y squared. How do we expand x plus y squared? This is the same as x plus y into x plus y. X plus y squared means x plus y into x plus y. When we expand this, we use the unknowns in the first bracket to multiply by the unknowns in the second bracket. So we factor out x, we multiply by x plus y. And again, now we take this other value, which is plus y, we multiply by x plus y. So in expanding this, x times x is x squared plus x times y is xy plus y times x is yx plus y times y is y squared. So what do we get here? This is x squared. Then we collect the like terms. From here, the like terms are xy and yx. So here we have xy plus yx. We just add the coefficients of xy. The coefficient of xy here, there's a silent 1, and another coefficient of yx is 1. So you simply add 1 plus 1, which is 2. Then you replace by, you just insert xy, then plus y squared. So when we expand, the expansion of x plus y squared is x squared plus 2xy plus y squared. From here, class, we will look at, let's say, a value like x times x times x times x. What do we get? We get x raised to power 4. So in the laws of indices states that when you are multiplying similar values, you just add their powers. So this is the same as x raised to power 1 times x raised to power 1 all the way times x raised to power 1 times x raised to power 1, which is equal to x raised to power 1 plus 1 plus 1 plus 1, which is 4. Suppose we divide this by, again, x times x times x times x, which again is equal to x to power 4. So when we divide this, the laws of indices states that in division, you just write the value of x raised to power 4, then you subtract the powers. So it is x raised to power 4 minus 4, which is the same as x raised to power 4 divided by x raised to power 4. This gives us x raised to power 0. Any number or any value raised to power 0 equals to 1. So put this at the back of your mind. We go to a value like x plus y raised to power 1. How do we expand this? There's something I want to arrive at, so I just want you to follow me and I will arrive at this very easily. So x plus y raised to power 1 is the same as 1. The coefficient of x here is 1 times x. This is the same as 1 times x plus 1 times y, which is the same as x plus y. So from here, the coefficient of x is 1 and the coefficient of y is 1. So this x plus y equals to x plus y raised to power 1 equals to x plus y. So our first value, when we say x raised to power 0 is equal to 1, which is also equivalent to x plus y raised to power 0 equals to 1. So if we have x plus y raised to power 0 equals to 1, x plus y raised to power 1 equals to x plus y. But we are interested in the coefficients. The coefficients. So here we have 1, the first value as 1. Second value, we have the coefficients of x is 1 and the coefficient of y is 1. So for this value is x plus y raised to power 0. And this value is x plus y raised to power 1. The next one, let's get x plus y raised to power 2. This is the same as x plus y into x plus y. So when we expand this, we already expanded this. The expansion, we got it as x squared plus 2xy plus y squared. Remember in our first example when I was telling you a way of expanding x plus y squared. So the coefficients of this, of x squared is 1, coefficient of 2xy is 2, and coefficient of y squared is 1. So what if we want to expand x plus y cubed? X plus y cubed is the same as writing x plus y multiplied by x plus y squared. X plus y cubed is the same as x plus y multiplied by x plus y squared. Because laws of indices, again, if these are the same, you simply add the powers. So when you add this to this, you get 3. So what do we get when we expand this? The expansion of this is here. So here we have x plus y into the expansion of this is x squared plus 2xy plus y squared. So open the bracket, you multiply x by what's on the other side of the bracket, x into x squared plus 2xy plus y squared. Then plus y here into x squared plus 2xy plus y squared. So from here we open it, this is x cubed, x times x squared is x cubed, plus x times 2xy is 2x squared y. X times 2xy. There's x here and there's x here. Simply add the powers of the x's, which is 2, and then place y there. So it is 2x squared y. Then x times y squared is just xy squared. Then on this side plus y times x squared is yx squared plus y times 2xy squared. So if y is here and y is here, simply multiply y by y, you get y squared. So it is, you replace here, you get 2x, then y squared. Then lastly, y times y squared, simply add the powers, y cubed. Then from here, collect the like terms. Here we have x cubed plus, we have x squared y here, 2x squared y, and then here also we have x squared y, x squared y. These are like terms. So just add their coefficients, you get 3 x squared y. Then you come to this, we have xy squared. This side we also have xy squared, this and this. Xy squared, xy squared. So add their coefficients, that is 1 plus, there's a silent 1 here. 1 plus 2, you get 3. Then you simply replace the values of the unknowns, which is xy squared. Then lastly, plus y cubed. So the expansion of x plus y raised to power 3 is x cubed plus 3x squared y plus 3xy squared plus y cubed. Therefore, here we simply write the coefficients of these values. The coefficient of x cubed is 1. The coefficient of 3x squared y is 3. Just take the number. Then the coefficient of 3xy squared is 3. And finally, the coefficient of y cubed is 1. So let's do one for x plus y raised to power 4. Then I will tell you how the trend on this is moving, how the trend on this is achieved. So from here, now let's do x plus y raised to power 4. So this simply means x plus y times x plus y raised to power 3. So there's a sequence that we are following. But x plus y raised to power 3, we already found it to be x cubed plus 3x squared y from the previous one that we've just gotten. That is x cubed. When you expand this, the expansion of this is x cubed from the previous example, plus 3x squared y plus 3x y squared plus y cubed. So what we get in this is the expansion of this. Then we multiply it by y plus x plus y. Again, open the brackets. So this x multiplies x cubed plus 3xy, 3x squared y plus 3xy squared plus y cubed plus y, again multiplied by the whole of this, which is x cubed plus 3x squared y plus 3xy squared plus y cubed. Close the bracket. Then we open the bracket. When we open this, what do we get? This is x raised to power 4. I told you just simply add the powers when they are like terms, when they are x and x or y and y, non-values, not non-values but like terms, x and x. Then here you add to x times 3x squared y. Simply add the powers, multiply x and x, you get x by x squared. You get 3x raised to power 3 y. Then here plus x times 3xy squared is 3x squared y squared. Then x times y cubed is x y cubed. Then open this again. You add to y times x cubed is yx cubed. Plus, you just replace the sign, y times 3x squared y. So it is y and y that brings y squared. So this is 3x squared y squared. Then here again, y times 3xy squared. You get 3xy cubed. Y times y squared is y cubed. Therefore, the last one is y times y cubed. You get y raised to power 4. Then again collect like terms. This one is, for this is x raised to power 4. Then plus, we have x cubed y, 3x cubed y. On this, we have x cubed y here. So this and this are like terms. We have x cubed, we have x cubed. We have y, we have y. The coefficient of x, yx cubed is 1. You simply add it to 3, you get 4. Then replace the value for x and y, which is x cubed, y. Then here, plus, this one we have 3x squared y squared. On this side, we have again 3x squared y squared. So that gives you 6x squared y squared. Then again here, we have xy cubed, xy cubed. So xy cubed plus 3xy cubed, you get 4xy cubed. Then lastly, we have this, which is plus y raised to power 4. So the coefficients of this is 1, coefficient of 4x cubed y is 4, coefficient of this value is 6, coefficient 4, and coefficient here 1. So from our shape, we said, from our shape here, x plus y raised to power 0 was we had 1, we have 1. Then x plus y raised to power 1, we have 1 and 1. Then x plus y raised to power 2, we have 1, 2, 1. Then x plus y raised to power 3, we have 1, 3, 3, 1. Then x plus y raised to power 4, we have this one, coefficient here is 1, 4, 6, 4, then 1. So if we want x plus y raised to power 5, what will we get? From here, we have 1, then 1, 1. Then at the beginning we have 1s, and at the end we have 1s. So we know that our next value has a 1 at the beginning and 1 at the end. So what are these values in between? So how did we get these values? This value we got it by adding 1 plus 0, you get 1. Then when we come here, just put 1 at the beginning, 1 at the end to make your work so easy. And then add 1 plus 1. When you add these two, gives you 2. Then how did we get these values? We have 1 at the beginning, 1 at the end. Then 1 plus 2, you get 3. Then 2 plus 1, you get 3. So come here again. You have 1 beginning, 1 end. Then 1 plus 3, you get 4. Then 3 plus 3, you get 6. Then 3 plus 1, you get 4. So how do we get our next values? You simply add, put 1 here and 1 there. Simply add 1 plus 4, you get 5. 4 plus 6, you get 10. 6 plus 4, you get 10. And 4 plus 1, you get 5. So suppose we want x plus y raised to power 6. What do we get? 1 here and 1 here. So when you have 1 here, 1 plus 5, you get 6. 5 plus 10, you get 15. 10 plus 10, you get 20. Then 10 plus 5, you get 15. Then 5 plus 1, you get 6. Then let's get the next value, x plus y raised to power 7. What do we have? 1 here, 1 here. So 1 plus 6 is 7. 6 plus 15 is 21. 15 plus 20 is 35. 20 plus 15 is 35. 15 plus 6 is 21. 6 plus 1 is 7. So when we look at this, you can go all the way to x plus y raised to higher numbers by simply just following what we've done. So number one, we are forming something which is looking like a triangle. As you can see, this shape is looking somehow like a triangle. So this triangle was formed by a person called Pascals. Pascal. This triangle is called a Pascal triangle. This is a sign of a triangle. And we call it Pascal's triangle. So Pascal was a French person. He was from France. Pascal was born in 1623 and Pascal died in 1662, which means that Pascal was 39 years, lived for 39 years, just slightly more than the number of years Jesus Christ lived on earth. But the only difference is that Jesus is life and Jesus is forever living. Then Pascal was a physician. Pascal again was a theologist, and Pascal was a serious mathematician, just like myself. I know they say never blow your own trumpet, but if you don't blow it, nobody will blow it for you. So so class, from there we will just take examples and tell you how to solve the challenges using Pascal's triangle. So, using Pascal's triangle, you are given a equation like a plus h raised to power 4. Then the question will read, expand a plus h raised to power 4. How do we expand this? Simply, in your mathematical tables class, don't sweat so much mastering this often. The reason why I have this Pascal's triangle in my head is because of experience. But don't sweat so much. Work has been made easy. Just use your mathematical table to get the coefficients of 4. So in our case, the coefficients of 4 are 1, 4, 6, 4, 1 from your mathematical table. Then after getting the coefficients, just simply write the value of a and h where they are. Here, ah. Again here, just combine the two unknowns, ah, here ah, here ah, and here ah. Then simply join them by the addition sign. Are we together, class, up to that point? Number 1, write the coefficients of 4 from the mathematical table. Then the values of ah, combine a and h. Write them just next to the coefficients, the numbers. Then add them using a positive sign, plus. Then after that, be very careful, class. The first value, which is a, will be decreasing from the power 4 to 0. If the power was 5, it will decrease from 5 to 0. So let's decrease it. So we start there by 4, then 3, then 2. This is a raised to power 2, this is a raised to power 3, then a raised to power 1, and then finally a raised to power 0. Then the value h will increase from 0 to the highest power, to 4. So h will increase from 0, h1, h2, h3, h4. Then class, just simplify this. Any number or any letter raised to power 0 is 1. Therefore, 1 times a raised to power 4 is a raised to power 4 plus, this is 4 a raised to power 3h. Of course, there's a silent 1 here. Plus, this is 6 a raised to power 2, h raised to power 2. Then here there's 4a raised to power 1, h raised to power 3. Then finally, 1 times 1, a raised to power 0 is 1, which is 1, times h raised to power 4 is just h raised to power 4. There are some observations that we'll make here. Number 1, the first observation is that as a decreases to 0, h increases from 0 to the highest power. The second observation is that when you add the two powers, when you add these powers, you will get the value here, which is 4. So 4 plus 0 is 4, 3 plus 1 is 4, 2 plus 2 is 4, 1 plus 3 is 4, 0 plus 4 is 4. So the expansion of a plus h raised to power 4 is this. Is a raised to power 4 plus 4a raised to power 3h plus 6a squared h squared plus 4a h raised to power 3 plus h raised to power 4. In this is referred to as our first term. This is our second term. This is our third term. This is our fourth term. And lastly, this is our fifth term. Another observation that we'll make is that when we are told to expand a plus h raised to power 4, our total number of terms will be 5. If you are told to expand a plus h raised to power 5, our total terms will increase by 1, which is, we'll have 6 terms. If we are told to expand a plus h raised to power 7, our total number of terms will be 8. So class, from here, what if we had this as a negative sign. If we had this as a negative sign, a plus h raised to power a minus h raised to power 4. Quickly, if you're told to expand this, simply write the values as they are. But now, I want to give you another method. It is just the same. You simply replace, let's do that, and then I give you a tabular form now, the easiest way again now to get this. So the values are 1, 4, 6, 4, 1. Then as I told you, just replace a and h. But this time round, h, you take it with its sign. So this time round, h is, it is minus h. Class, be attentive. This is a, take it with minus h. A minus h. A minus h. A minus h. Then simply join them with a plus sign. Then after that, we agreed that a decreases from 4, then a3, a2, a1, a0, while h increases from 0, 1, 2, 3, 4. So when you expand this, it means a raised to power 4, any number, any value, be it negative or positive, raised to power 0 is 1. So this is 1. So a raised to power 4 times 1 is a raised to power 4. Then here, we have 4a cubed, 4a raised to power 3 times minus h, minus h. So it is negative times positive, you get negative. Then you simply replace the values, which is 4a cubed h. Then here, be attentive here class, this is minus h squared. It means minus h times minus h. Negative times negative is positive. Therefore, that is positive, then h times h is h squared. So when we come here, we have 6, it is positive, 6a squared h squared. Then when you come here, you simplify this first. So this is going to give us minus h times minus h times minus h. This minus h times minus h is h squared, then times minus h. So this is positive h squared times negative h, gives you negative h cubed. So this value, this sign, positive times negative, you get negative 4a h cubed. Then lastly, here we have h, just look here, minus h. For here, minus h raised to power 4 minus h means minus h times minus h times minus h times minus h. This and this is positive h squared. Minus h times minus h is h squared. Then minus h times minus h is again h squared. So h squared times h squared is h raised to power 4. It is positive. Therefore, positive and positive is positive. Then a raised to power 0 is 1. So this is going to be h raised to power 4. So that is the difference when you use negative and positive. The only thing that will change are the signs. Where there are even numbers, the signs will remain positive. Where there are odd numbers, the signs will remain negative. Like there's an odd number on h is negative. There's even number on raised to power h is positive. There's odd number is negative. So class, let's expand this, but I want to show you another way. Let's say 1 plus 2x raised to power 5. The question will be like the way I'm telling you. So you need to believe in me 101%. Any person telling you that Babu is telling you lies, know that that person, number one, is not educated. Number two, that person is not following what we are doing. This, I'm telling you, and is very, very, very correct. So these questions will come, and I can assure you is going to come in your exams. It might not be the same question, but the same trend on binomial expansion. So 1 plus 2x raised to power 5. The first thing, draw a table. Draw a table, just write the coefficients. Then draw a table, write down the coefficients of 5. The coefficients of 5 are 1, 5, 10, 10, 5, 1. This is in your mathematical table. Again, don't strain yourself in mastering or cramming this. It is not easy to cram numbers, so mathematics is the only subject that you must understand fully. You cannot just cram it. You must master it. Then here, our first value is 1. Write your 1 here. Our second value is 2x. Write your 2x here. Then just draw a table. Then class, along this horizontal row, just fill in 1 everywhere. Then along this horizontal row, fill in 2x. Then the next rule is, as 1 decreases from 5, 5, 4, 3, 2, 1, 0. 2x increases from 0, the whole of this is the whole of 2x, then 1, then 2, then 3, then 4, then 5. Next thing you do is simply expand these values. 2x raised to power 0 is 1. Any number raised to power 0 is 1. 2x raised to power 1 is 2x. 2x raised to power 2, you simply multiply. It is like 2x times 2x. So 2 times 2 is 4. X times x is x squared. Then 2x raised to power 3 is the same as 2x times 2x times 2x. 2 times 2 times 2 is 8. X times x times x is x cubed. So this is 8x cubed. Then 2 raised to power 4 is 2 times 2 times 2 times 2x. 2x times 2x times 2x times 2x. You get 16x raised to power 4. And then lastly, 2x raised to power 5 is 32x raised to power 5. But simply just use a calculator. It's very easy to use a calculator because you are allowed to use a calculator. During my time, it was a little bit of the Stone Age. We just used to, we didn't have the opportunity to use a calculator. So, after that, just multiply what is here by the coefficient of this, by the coefficient of this. Then you add them as you go along the horizontal line. So, in the first value, we will have 1 times 1. Any number, 1 raised to power any number is 1. 1 raised to power 5 is 1. 1 raised to power 0 is 1. 1 raised to power million is 1. 1 raised to power billion is 1. So 1, this remains 1. So 1 times 1 is 1. Then 1 times 1, the values of this are here. So we will use this. So 1 times 1 times 1 is 1. Then join them with a plus. 5 times 1 is 5. 5 times 2 is 10x. 5 times 2x is 10x. 10 times 1 is 10. Then 10 times 4x squared is 40x squared plus 40x squared. Plus, here 10 times 1 is 10. 10 times 8x cubed is 80x cubed. 80x cubed. 5 times 1 is 5. Then 5 times 16 is again 80 x raised to power 4. Then lastly, 1 times 1 is 1. 1 times 32x raised to power 5 is plus 32x raised to power 5. So the question can tell you to expand 1 plus 2x, then find the fourth term, or find the fourth term of the expansion of 1 plus 2x raised to power 5. So you simply count the fourth term, 1, 2, 3, 4. So the fourth term is this. The fourth term is 80x cubed. Fifth term is 80x raised to power 4. Sixth term is 32x raised to power 5. Third term is 40x squared. Second term is 10x. And the first term is 1. So I want to read for you some of the comments. Today's class is very short. Don't be worried. We have not finished, but in the next few minutes we'll be done. I just want to read for you some of the comments from my brothers and sisters who are online. I can see Oko Steven is saying, Babu, making mountains into valleys. Thank you, bro. Sharon Perez, good one, Fortune. We have Maureen Adis, love you, baby. Good work. Hey, this is too much love. Love you more. Kennedy Ochola, watoto watapita maths. Mimi hata mtoto wangu saizi anasikiza na nimemweka hapa na bundles kibao. Asante sana. We have Korir Nelson, Babu, good work all the way from Rift Valley. We have Frank Makamba Kinywa, good work, Babu. Although some of us are graduate, although we have brothers and sisters in high school. Peter Wanambisi, wonderful. Kevin Alan, keep it up. Wanjala Steven, thanks, Babu. This time round, my brother is going to pass exams. Kwamboka Beatrice, this is great. I love it. So this is on YouTube. Then on my Facebook, Frank Kariuki, I'm so pleased with this. Hadi nalala nikikumbuka na anacheka. Kudos, bro. Mark Dave Busiana, I wish you are my maths teacher. Eda Karembo, I will go back for my school fee. This is wonderful. Chalo Webrozi, that's good, Professor Babu. Benson Okwanyo, good work, Prof. Onsare Chandi, this is great. Nelson Koech, we love you. Just continue with the good work. Gentrix Talam, I'm following, although almost getting lost. Shadrach Okach, boss. Abdi Malik Sadiq, wow, this is amazing, sir. Somebody is complaining, teacher unaniziba. Wacha nitengeneze. Many more comments, you can read them. Let's go on another example. Another example, suppose you are told to expand 1 plus 2h raised to power 6. Expand this, hence solve 1.02 raised to power 6. This is a little bit, it's not complicated. It's just 1 echelon higher, but it is very cheap. This is very easy. 1 plus h raised to power 6, hence solve 1.02 raised to power 6. The first thing you do, expand this. Don't be worried about this when you see. Just let it relax, then expand this. Write the values for 6, the coefficients for 6. Go to the table, just write coefficients. Then the first value is 1. And the next value is 2h. Then coefficients are 1, 6, 15, 20, 15, 6, and 1. So where this value is 1, just fill in 1 everywhere here. Then this value is 2h, just fill in 2h. Then as 1 decreases from 6, 5, 4, 3, 2, 1, 0, 2h increases from 0, 1, 2, 3, 4, 5, 6. Then open it up, solve it. So 2h raised to power 0 is 1. 2h raised to power 1 is 2h. 2h squared is 4h squared. 2h cubed is the same as 2h times 2h times 2h, which is 8h cubed. Then 2h raised to power 4 is the same as 2h times 2h times 2h times 2h, which is 16h raised to power 4. Then here 2h raised to power 5 is 32h raised to power 5. Here 2h raised to power 6 is 64h raised to power 6. Then simply multiply as you add. So 1 times 1 times 1 is 1 plus 6 times 1 is 6 times 2h is 12h plus 15 times 1 is 15 times 4h is 4h squared is 60h squared plus 20 times 1 is 20 times 8 is 160 h cubed plus 15 times 16 h raised to power 4. What do we get by this? 15, that is 16 times 15. You get 240 h raised to power 4 plus 6 times 1 is 6 times 32, that is 32 times 6 is 192, that is 192 h raised to power 5 plus lastly 1 times 1 is 1 times 64 h raised to power 6 is 64 h raised to power 6. So our answer is 1 plus 12h plus 60h squared plus 160h cubed plus 240h raised to power 4 plus 192h raised to power 5 plus 64h raised to power 6. Then the question tells you, hence solve this value 1.02. So how do we solve this? It is simple, class. Don't panic when you see such a question. This value of 1.02 raised to power 6. Simply split 1 and 0.02. So this is going to be 1 plus 0.02. Remember, we are dealing with binomial. Bi means 2. So this is 1.02. You put it in binomial form, which is 1 plus 0.02. You just remove 1, then you add it to 0.02 raised to power 6. Therefore, after that, you equate it to this, which is 1 plus 2h raised to power 6, equate it to 1 plus 0.02 raised to power 6. Now, this 6 is the same as this 6. This 1 is the same as this 1. Then 2h is the same as, so you equate 2h equals to 0.02. Therefore, the value of h, divide everything by 2, divide this by 2. So 2 divided by this is 0.01. So from our equation, just look here, 1 plus 12h plus 60h squared plus 160h cubed plus 240h raised to power 4 plus 192h raised to power 5 plus 64h raised to power 6. Then our value h equals to 0.01. So in this, just replace where there is h, you replace 0.01. So from here, we have 1 plus 12h is 0.01. Then here, plus 60 into h is 0.01, but it is squared. Plus 160, h is 0.01, but it's cubed. Plus 240, h is 0.01, but it's raised to power 4. Plus 192, h is 0.01, but it's raised to power 5. Plus 64 here, h is 0.01 raised to power 6. Therefore, when you expand this, you get 1 plus 12 times 0.01 is 0.12 plus 60 times 0.01 squared. 0.01 squared is the same as 0.01 times 0.01 times 60. So this is going to give us for 0.0060 plus this is going to give us 0.01 times 0.01 times 0.01. So this is 1, 2, 3, 4, 5, 6. So these are 3. Then 0.1, 2, 3, 4, 5, 6. Plus this is going to be 8, 0.002, 3, 4, 5, 6, 7, 8. Plus for this is going to be 0.10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then plus this is going to be 12, 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So when we add this, sorry, my microphone is out, just a minute. Okay. So when we add this, this is 1 point. Now let's just add this. You can use a calculator to add this very fast. Let me use a calculator here. So we have 1 plus 0.12 plus 1, 2, 3, 4, 0.1260 plus 0.100016 plus 1, 2, 3, 4, 5, 0.1, 2, 3, 4, 5, 5 zeros, then 2, 4 plus 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 0.1, 2, 3, 4, 5, 6, 7, then 1, 9, 2 plus 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 zeros, then 6, 4. So the answer we get equals to 1.126162 419264. So we are told to expand, we were told to expand 1 plus 2h raised to power 6, hence solve 1.02 raised to power 6. So when you are given such, our answer is this. So you can be told to different significant figures. But if you are not told, if the question is open, you just leave it like that. If you are told to one significant figure or to one decimal point to two significant figures, you just move from the decimal, then you count 1, 2. So this is going to be 1.13 if it is to two significant figures. So class, next, which is our last example. Our last example, you are told to expand. Expand 9x squared plus 6x plus 1 raised to power 3, hence solve 1.33 raised to power 6. Be very careful. You are told to expand 9x squared plus 6x plus 1 raised to power 3. Hence solve 1.33 raised to power 6. How do we go about this? First of all, deal with this, which is 9x squared plus 6x plus 1. How do we simplify this? We first of all, this is raised to power 3. So first of all, simplify the quadratic equation. Look for two numbers. When you multiply them, gives you 9x squared. But when you add them, gives you 6x. Therefore, those two numbers are 3x and 3x. So when we expand this, is going to be 9x squared plus 3x plus 3x. When you multiply these two, gives you 9x squared. But when you add them, gives you 6x plus 1. Raised to power 3. From here, expand, simplify this to, the common factor here is 3x. Then 3x goes into 9x squared, 3x times. 3x goes into 3x once. Then plus, the common factor here between 3x plus 1 is 1 into 3. 1 goes into 3x, 3x times, plus 1 goes into 1 once. Therefore, because these are the same, just factor, take the 3x, add to 1. Then because these are the same, we only take one value, which is 3x plus 1. Then the whole of this is raised to power 3. Now, this and this are the same. It's like a times a is a squared. So this is 3x plus 1 squared. Then we also have raised to power 3. So this is 3x plus 1 raised to power 6. Now you can see there's a similarity between this and this. This was raised to power 3, this is raised to power 6. But when we simplify this quadratic equation, we get 3x plus 1 raised to power 6. So we brought it down to a binomial expression, which is 3x plus 1. So we expand it using the values as 6. So values of 6, just write normally, write your coefficients. Then the first value is 3x, the next value is 1. Then values of 6 are 1, 6, 15, 20, 15, 6, 1. Then here we have 3x, 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 3x. Then here we have 1, 1, 1, 1, 1, 1, 1. So this value, the first value, will decrease from 6 to 0. 6, 5, 4, 3, 2, 1, 0. Then this value increases from 0, 1, 2, 3, 4, 5, 6. From here, when we expand this, what do we get? This is 3x raised to power 6. So it is the same as, let me put my rough work here. 3x raised to power 6 is the same as 3x raised to power 3 by 3 raised to power 3. 3 raised to power 3 is 27. Times 3 raised to power 3 is 27. So 27 times 27, this is 49, 4, 18, 14, 5. 9 to 7. That is 729. So for this first value is 729x raised to power 6. The next value is 3 raised to power 5. That is 3 raised to power 2 times 3 raised to power 3. 3 raised to power 2 is 9 times 3 raised to power 3 is 27. So 27 times 9, 63, 6, 18, 24. That's 243. So 243 times 6. This is 243 times 6 times 1. So this times 6, 18, 24, 5, 2, 14. That is 1458, but you can use your calculator. 1458 x raised to power 5. The next one is 3 raised to power 4 is 3 raised to power 2 times 3 raised to power 2, which is 9 times 9, which is 81. Then 81 times 15. Times 15, that's 5, 40, 1, 8. That is 5, 1, 12, 15. You be careful here. I think I'm right. I'm right. In fact, I'm right. But you confirm. That is 12, 15. X raised to power 4. The next 3 raised to power 3 is 27. 27 times 20 times 1 is 540. X raised to power 3. Then 3 raised to power 2 is 9. 9 times 15, 135. Is it 15 for 135? 45 for 135. So this is 135 x raised to power 4. Then 6 times 3 is 18. No, this is squared, not raised to power 4. This is 18x. Then this is 1. So our values are this. So when you are told to expand this, we just simply add them. So we've already multiplied. So our values is this. Our value, our answer when you expand is 729 x raised to power 6 plus 1458 x raised to power 5 plus 1215 x raised to power 4 plus 540 x raised to power 3 plus 135 x raised to power 2 plus 18x plus 1. Then remember class, you are told hence find the value. You are told to expand 9x squared plus 6x plus 1 raised to power 3. Hence solve 1.33 raised to power 6. Again, the value that we got here were 3x plus 1 raised to power 6. When we simplified this, you equate it to make this binomial. How do you make this binomial? It is the same as 1 plus 0.33 raised to power 6. So 1.1 plus 0.33 raised to power 6. This 3, this 6 is for this 6. This 1 is this 1. Therefore 3x here, you equate it to 0.33. So x value, you divide everything by 3, this side by 3. X is, okay, x equals to 0.33 divided by 3. X equals to 0.11. So where there is x, you replace it with 0.11. So if there is x is here, replace it with 0.11 all through. Then you simplify your answer. Or alternatively, the question can tell you, find, hence solve this. That is just simply replacing the values for x and then you solve it. So when we solve this, it will be 729 into 0.11 raised to power 6 plus 1458 0.11 raised to power 5 plus 1215 0.11 raised to power 4 plus 540 0.11 raised to power 3 plus 135 0.11 raised to power 2 plus 18 0.11 raised to power 1, which is 0.11 plus 1. So when we use our calculator, 0.11 raised to power 6 from the calculator, 0.11 raised to power 6, you get 1.771561. times 10 raised to power negative 6 plus, now you multiply by 729. What do we get by 729? You get 0.11 sorry, that is 729 multiplied by 0.11 raised to power 6. This, the first value you get 0.001291 467,969 plus this value is 1458 multiplied by 0.11 raised to power 5. You get 0.023481 2358. Then the next one is 1215 multiplied by 0.11 raised to power 4. You get 0.1778815. Then the next one is 540 multiply by 0.11 raised to power 3. You get 0.71874. Then 18 multiplied by 0.11, 0.11, you get 1.98. Then lastly 1 can be 1.00. So you add this. When we add this very fast, 9, 6, you be careful because of the signs. That's 17, 1, 8, 13, 3, 1, 10, 15, 5, 1, 5, 7, 8, 10, 0, 1, 10, 18, 26, 30, 0, 3. That is 5, 9, 17, 24, 4, 2. That is 3, 6, 13, 21, 1, 2. You carry 2 up. I hope this one you know. This is 2, 4, 11, 12, 22, 2, 2. That is 2, 3, 10, 19, 9, 1, then 1, 2, 3. So this is our answer. So class, the last example that we will do, those ones were applications of binomial expansion. Suppose you are told to solve x plus 2y raised to power 7. I'm just trying to increase the powers. So this, just write the coefficients of 7. This is our last example. Write value of x, then write value of 2y. Then from here, the coefficients of 7 are 1, 7, 21, 35, 35, 21, 7, then 1. So then just write values of x and write values of 2y. Same way class, very easy. Then after that, x decreases from 7, 6, 5, 4, 3, 2, 1, 0. As 2y increases from 0, 1, 2, 3, 4, 5, 6, 7. So you are told to expand this and get the fifth term. So the expansion of this, we simply expand this. So 1 times x raised to power 7 times 2y raised to power 0 is 1. So this is x raised to power 7 plus 7 times x raised to power 6 times 2y. This is 7 times 2 is 14. Then x raised to power 6 y plus 21 times x raised to power 5 times 2y squared. This is 4y squared. 4y squared. So it is 21 times 4. 21 times 4, you get 84. So this is 84 x raised to power 5 y raised to power 2 plus here 2y cubed is 8y cubed. 8 times 35, 35 times 8, 44, 24, 28. That's 280 x raised to power 4, then y raised to power 3. Plus next here, 2 raised to power 4 is 16, 2y raised to power 4 is 16y raised to power 4. That is 2 times 2 times 2 times 2. 4 by 4 is 16y raised to power 4 times 35. So that is 35 times 16. This is 33, 18, 21, 5, 3. This is 0, 6, 5. This is times, this is plus. So it is 560 x cubed y raised to power 4 plus this is 2 raised to power 5. 2y raised to power 5 is 32 y raised to power 5. Therefore 32 times 21. 32 times 21. 2, 3, 4, 6. 2, 7, 6. This mathematics is so easy. Now this time round, this is as easy as chewing a lollipop. So this is 672 plus 672 x squared y raised to power 5 plus 2y raised to power 6 is 64 y raised to power 6 by 7. So this is 64 by 7. 28 to 44. 28 to 44. That is 448 x y raised to power 6 plus lastly 2y. This is 1 times x raised to power 0 is 1 times 2y raised to power 7. This is 128 y raised to power 7. So plus 128 y raised to power 7. Then make sure you write your answer neatly. So you just open this, write it neatly here. X raised to power 7 plus 14x power 6y plus 84x5y power 2 plus 280 x raised to power 4y raised to power 3 plus 560 x raised to power 3 y raised to power 4 plus 672 x raised to power 2 y raised to power 5 plus 448 x y raised to power 6 plus this 128 y raised to power 7. So you are told to expand, get the expansion of x plus 2y raised to power 7. This is the expansion. Then you are told to get the fifth term. So this is the first term, second term, third term, fourth term, fifth term. So our fifth term fifth term equals to 560 x power 3 y raised to power 4. That's it. So class binomial expansion will be set and be ready for it. For today, our class ends there. I want to thank you very much, my class, for having confidence in me. And once again, trust me. Just trust me with your students, trust me with their children as parents, and I will make sure that their lives change. I will ensure that that student who gets an E in mathematics, chemistry, and other subjects graduates to getting a B and above. That student who gets a B will get an A or A minus. That student who gets an A minus will get an A. And that student who gets an A will strengthen his A. And remember that education is one of the key pillars to success. Let's love education. Thank you very much. And there is homework that is going to run on the screen just right away. Make sure you do the homework. And it's on the slide. Thank you and God bless you all. I hope you enjoyed the class. Thank you.